Have you ever contemplated why an apple falls from a tree? Or why we stay firmly planted on the ground instead of floating off into space? These everyday occurrences are governed by a fundamental principle that applies universally, the law of universal gravitation. Conceived by the brilliant mind of Sir Isaac Newton in 1687, the law of universal gravitation is a cornerstone of physics. It elegantly explains how every object in the universe, no matter how small or how large, exerts a force of attraction on every other object. Imagine the universe as an intricate dance of celestial bodies, each one pulling and being pulled by every other body. This is the essence of the law of universal gravitation, a principle that states that every point mass attracts every other point mass in the universe. The strength of this attraction is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. In simpler terms, objects with greater mass exert a stronger gravitational force. The further apart the objects, the weaker the gravitational pull. It's like being at a party. The most influential guests naturally draw more people towards them, but the further you are from these guests, the less you feel their influence. This principle, known as the inverse square law, explains why as the distance between two objects increases, the force of gravity diminishes rapidly. It's why we feel the Earth's gravity more strongly than the pull of distant stars and galaxies. Another key point about the law of universal gravitation is its universality. From the tiniest particles to the grandest galaxies, every object with mass is subject to this law. It governs the behavior of all gravitational interactions, making it a universal principle. The law of universal gravitation also embodies symmetry. The force of gravity acts along the line connecting the centers of two objects, pulling them together. It doesn't care about the shape or composition of the objects involved. This law has profound implications, explaining not just why apples fall from trees, but also how planets orbit stars, how moons circle planets, and why tides ebb and flow. It is the foundation of Newtonian mechanics and a pivotal principle in our understanding of the universe. So, the next time you see an apple fall from a tree, or gaze up at the moon in the night sky, remember the invisible dance of attraction happening all around us, the universal application of gravity. It's a dance that has been choreographed by nature and deciphered by human curiosity and intellect, a testament to our ceaseless quest to understand the cosmos.